Alright, another draft science video presentation. Alright, PBS video. This is from a while back. I've probably done it before, but two slit stuff, and it just, I figured I can illustrate to you every point where they say things that just aren't true. Now, it kind of begs credulity for some of these things for us to say, oh, they just missed it. They didn't see that. They don't understand the principle. They're just so overt. So I'm going to call them lies because they got to know that what they're saying is exaggeration, that it's quote mining. They've mined the evidence. They've chosen deliberately to propagandize, to exaggerate some features and completely hide other features. This is shenanigans, so I can at least say that. This is shenanigans, right? It's not honest physics. It's not good science. It's really bad science. It's the number one thing you want to avoid when you're doing science is cheating. And this is cheating. Okay, this is propaganda. It's not an honest debate. It's not honest evidence in the trial. It's like, bringing up somebody's, sexual past in a rape case or this or that or something. It's just this, it's this way of saying, take your eye off the ball and look at our Jesus instead. It's what religious people do. It's not what scientists are supposed to do. That's the argument. So, I'm just saying, it's lying. It's deception. It's chicanery. It's bullshit. Alright, so let's play this crap.
Strangest experimental results ever observed is going to be that of the single particle double slit experiment.
Right. So, number one, that this has ever been observed, this single particle blah blah double slit thing. They claim to do it, but we don't see it. We don't even see anything from the original French guy that was supposed to have done it. That's not even anywhere you can find. So, yeah, sure.
It's one of the most stunning illustrations of how the quantum world is very, very different from the large-scale world of our physical intuition.
Right. So again, they use the word intuition, like you're being a simpleton. The real universe is so much cleverer or so much more honest than our intuition. Our intuition, we get fooled by cuteness and we get fooled by different things, and so our intuition sucks. But this is not proof that the elemental universe is at all sophisticated or complicated or magical. And if they were honest to the facts, it's quite apparent that you don't need any of this woo.
In fact, it hints that the fundamental nature of reality may not be physical.
Okay, may not be physical at all. So, it's called physics. They don't care about physical. That sounds like religion to me. So you people who keep defending it, it seems like they're heading as fast as they can, to the wooey-verse. Let's just make reality what we want it to be.
At all, at least in any sense that we're familiar with.
It wouldn't matter. We're not familiar with subatomic particles in any real sense, and so who cares whether they're made, what they are made of, who cares? The concept that they should be able to say is solid is this idea that momentum is transferred, that one object affects the momentum, the movement of another object, and that effect always takes place in the world we see, in all of our real observations. It takes place at the speed of light. That there isn't any instantaneous knowledge gained anywhere, that this doesn't happen, that this quantum entanglement thing and all the rest of it doesn't have anything to do with the perceived realities, the physical realities, and it just has to do with the place you can't see. They're saying it happens on this other scale. It's just like the existence of their positrons and such. They'll call some kind of medical therapy, you know, positron emission therapy or something. The positrons are theoretical. They don't actually shoot them. They don't actually have a place anywhere. They happen inside the body. Okay, that it's their projection that there's a bunch of positrons doing something.
Let's start with the familiar. In fact, let's start with a rubber ducky. It bobs up and down in a pool, causing periodic ripples to spread out. Some distance away, those waves encounter a barrier with two gaps cut in it. Most of the wave is blocked, but ripples pass through the gaps.
Right, so this is just doing the water example. Now he could have chosen, I'm just saying, right, if you were going to be honest to the evidence, he could have chosen a single slit. And they could have shown these plain waves coming, just plain waves, no interference, no possibility for interference. Water waves, sound waves do not interfere in the single slit, and light does. So he could have started with the one that is anti-evidence, completely anti-evidence. I mean, it just basically says these are probably not the same things because the results are completely different. Water does something very different than what light does. The single slit demonstrates it. There's no way to pervert it, really, unless you do some elaborate nonsense and say, well, Huygens says blah, 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 blah. Well, why doesn't Huygens say that in water waves? And why doesn't Huygens say that in sound waves? So it doesn't make any sense. It clearly is, you just quote mine the evidence for the one that does look like, and it only looks like, okay, vaguely looks like, right? Because when you know what the real pattern is, it's not the same pattern again. The double slit is also counter evidence, because the one in light actually creates a different pattern than is created in water and sound. Substantially different. So what is this, right? What is this but propaganda? Are we to believe that he doesn't know what, he hasn't seen, he doesn't know that water does this, okay? Water waves do this, okay? And light does this. And of course he could draw it, ugly. That is, he could use a really, really tiny slit and pretend it just does this and then it does this. But it doesn't really matter. It's not the same pattern. This pattern, this interference pattern, is not the same as the pattern here, which is just going to be one solid bar of light. So why are they doing this? He doesn't know that? I'm supposed to believe he doesn't know? Yeah, come on. Yeah, he knows. And again, there's no math that works for waves. Even if I do the Huygens thing, I got the point sources in the wrong place. It doesn't work. Plainly doesn't work. And they know it, and they just don't care. They just slide right over the fact that, ooh, this evidence is ugly. Okay, this evidence is not very good. The fingerprints are on the end of the gun, not the trigger, this kind of stuff. And they just don't, hey, the gun has his fingerprints on it. Yeah, on the inside. Yeah.
When the new ripples start to overlap each other, they produce this really cool pattern.
So it's a really cool pattern. We have to do this crap. So people who watch this kind of, whatever you want to call it, need to stay in the world where you talk about cool stuff and neato. It's very neato. It's a neato pattern. Groovy. Very groovy pattern.
Is called an interference pattern. It's due to the fact that in some places, the peak of the ripple from one gap stacks on top of the peak from the other gap.
Right. You can have things that cancel in terms of you can cancel energy. I can hit something from this side and I can hit from this side, and they cancel out. Or I can hit them both at the one direction and the thing will move, blah, blah, blah. Not that complicated, really. But really has nothing to do with photons.
Making a more extreme peak. You also get more extreme dips when two troughs overlap. We call this constructive interference.
Right, it happens in water and it happens in sound. And why does it happen in those things? Because there's a medium. So again, this is another one of the huge lies and deceptions, is they're claiming there is a medium. Just call it what they think it is. There's an ether. Just say it. Say the word. Because that's what you're saying. You're saying there's some sort of goop that's vibrating.
But when the peak from one wave encounters the trough from another, they cancel out, leaving nothing. Destructive interference.
So this leaving nothing thing, again, is another thing they haven't proven. So they haven't proven no energy goes to the little dark spots. No proof at all. Okay, because they haven't looked to see if energy went there. You know, little bits of heat.
So we have these alternating tracks of wavy and flat water. Any type of wave should make an interference.
So any type of wave. So again, a type that isn't in a medium. A wave of what? A wave of bent space, a wave of anything. So they just, I mean, this is so casual and sloppy. These analogies, building up this analogy. It's so sloppy. It's like the Christian holding up the pocket watch and saying, you know, how could that come from nothing? Let me see you evolve one of those. They're doing this. It's the same tactic.
Pattern like this. For example, water waves and sound waves, but also.
So again, you know, yes, and the fact is that I can find just as many experiments demonstrating dissimilarity, okay, as similarity. So they've quote mined the evidence, and again, quote mined it. Like I said, the double slit doesn't demonstrate anything like the same theory. The two-wave notion doesn't work. It won't create the right pattern in any way. I mean, let's understand, it doesn't create the right pattern catastrophically, okay, in the sense that the waves are in the wrong place. You know, if you put them where it will work mathematically. So if I put the waves here, that means the wave center is here. Now, when they do the math, they know that's not true. They know that won't work. The bars will be twice as big, okay, there. If I use this in the math, this distance, if I use that in the math, the bars will be twice as big. Okay, so they're obviously going to be way in the wrong places. I mean, they're going to be way off, way the hell off. Not even close to the right answer. You can't get the right answer with this. Even if there wasn't two patterns, this won't get you the right bar size. It won't get you, because, well, obviously the bars are on an arc and blah, 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 blah. And I've explained all that crap. But this won't work. They know this is the math that works. This is the number, the distance, and this distance. These are the distances that work. So why play this game that somehow this is about two waves? It's not about two waves. It's actually about four waves. And if you have four waves, you have to put them in these ludicrous positions. Here, and here, and here, and here. That's not working for you. That's not going to get you anywhere. Real waves don't do that.
Light waves. This double-slit interference of light was first observed by Thomas Young back in
All right, so that's just wrong again. So, frankly, because we know Newton did all these experiments. He did the two interior surfaces facing each other, and he did the two surfaces not facing each other. He did the inside and the outside. So, he had all the pieces already done. So it was clearly a known phenomenon. Young added no. Young was a distraction, a terrible distraction, because Young's drawing isn't the real pattern. So it's just garbage. I mean, they know Young didn't see the real pattern. He didn't see the real complexity that this provides. It's not even that complex, frankly. You know, he had a crude instrument. He saw a crude pattern. And he just didn't know, okay, that this drawing just doesn't work. That first, this distance doesn't work. I mean, he probably should have known that. That this is a point source and this is a point source for vectors does not work. It will not work. It won't give you the right answer to where the bars are. And let's understand the real pattern has a glaring aberration effect, distortion, brokenness, strangeness in its patterns, and this won't do it. These two waves can't do it. There's no way to draw them. There's no way to manipulate them. There's no way to create the vectors you need to create these empty spots. It's just a fact. And they know this, right? You're telling me they don't know that? Yeah, they know that. So why are they hyping this? Because they have a whole other pile of shit they want to sell you. And they first have to sell you this lemon.
1801. A source of light passing through two very thin slits produces bands of light and...
So he shows it. He shows the double slit pattern, and now he'll say it produces bands of light on and off, on and off. Wait a minute. What's that? Off-ish? On-ish? Off. Wait. It doesn't just produce bands of light. And again, the understanding that you're projecting on a flat screen is fail. You won't see it as it is. You'll see it distorted. It'll look infinite when it's not. It's a pattern that's happening over arc seconds. They know what all this arc second crap means. They know all that stuff. They know this pattern is in space and it's flying through space. The pattern is already made at the source, and the pattern is just flying through space. It's just going like this through space. And obviously you'd have to look at it equidistant to see it in the right proportions. If I look at this part of it further away than this part, then this part's going to do exactly what my hands are doing right now. This part's going to look preposterously big, and this part's going to look tiny and small. So obviously they've never done that, right? So you're telling me this physicist has never thought about this concept, and knowing that, well, I can't look at something this way and compare it to something this way. That comparison would be stupid. He doesn't know that.
Dark stripes, alternating regions of constructive and destructive interference.
No, so really, like I said, the real story is to just break the photon, remake the photon. So it's just reconstruction. Okay, there's deconstruction and reconstruction. There's no destructive interference. Forces don't interact with forces. That's one of these physics rules out there. You can't make gravity bend something. You can't make magnetism bend a force. You can't make light bend a force. None of the forces can bend another force. They just can't do it.
On a screen. Of course, we now know that light is...
So we now know it. And why do we know it? Because we have perverted the evidence preposterously. There, right there, he's showing you a pattern, and he's pretending there's nothing to see here. It's just a bunch of bars straight across. And he knows it's not. So why is he saying it is? Again, except to be a liar and a propagandist, to maintain the authority of the Bible. Okay, the integrity of the Bible. I'm going to explain how you shove a Jonah into a whale's little tiny throat.
The wave in the electromagnetic field, thanks to the work of James Clerk Maxwell.
Right, so Maxwell doesn't have any of that crap in it. So they keep talking like Maxwell's math is a bunch of wave theory. No, it's a bunch of vector theory. It's a bunch of straight lines. Maxwell's drawings of charge, all straight lines. Okay, so the thing that has the admitting the force, right? You have these two charges and they're admitting a force to each other. They're communicating with each other. And it's all like, let's put another minus down here just to make it interesting, right? And Maxwell's equations will allow you to calculate the repulsion between these two, based on vectors. And the vectors are straight lines, straight lines, straight lines, straight lines, straight lines. And straight lines are coming off of this thing. And all you do is you count how many of these straight lines intersect with this object and how many of these straight lines intersect with this object based on distance. The further away it is, the less lines will hit it. It's all straight lines. All right, so Maxwell is all about the straight line. No waves in the math. There's no wave functions. No, you don't need any of that crap. So this is all, again, part of the distortion. They know that the basic mathematics in Maxwell's equations is about straight line vectors, not waves.
Century later, So it makes perfect sense that it should produce an interference pattern, right?
So again, it makes sense only if you pervert the evidence. It doesn't make any sense if you look at the single slit and compare the light in single slit and the water in single slit. You compare the two, you say, ah, doesn't make sense. Nope, don't look anything like each other.
But wait, we also know that light comes in indivisible little bundles of electromagnetic energy.
So this is another problem, right? Because although this idea that light comes in clumps is to my advantage in explaining the reason why Einstein and Planck and others were quantizing or clumping these forces is because that's how we have to detect them. We can only detect a photon because it hits one of our clump detectors. Okay, the detector tells you, you must hit me with energy enough to shoot an electron onto another plate, which shoots it onto another plate and shoots it onto another plate. You must, in a sense, create electricity. So whether it's a substance, I have to hit it with enough energy or energy in a specific way where I cause a current. So you could sort of understand if a photon was in pieces, what we call a photon, was a composite object, which shouldn't be that hard for you to understand just because your waves have to, it's not just one of these waves that's a frickin' photon. You don't cut it here and say, there, photon. You know that it's more than one. And so you just cut it into a frequency. To make a frequency, you have to have more than one player, right? One thing can't, I have a frequency all by myself. No. You know that no matter what it is, bullets, people, frogs, if it's going to come at you at a frequency, there has to be more than one of them. So they already knew that too. They know that. This isn't that complicated. But the idea is that the photon would hit, and then it would hit, and then it would hit, and then it would hit. And it's hitting in a progressive way, and it's going to cause ionization in a progressive way and cause what's called electricity. That is, an electron is going to sort of be exchanged between this and this and this and this and this and end up here. Now, it's not the same electron. It's just pushing electron, 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 electron. Same difference, though, right? I mean, if everybody's holding a piece of chalk and somebody passes a chalk to me and I pass my chalk to them and then they pass their chalk to them, it's not the same piece of chalk, but we know the chalk basically moved from point A to point B. Same difference. And that's all that's happening here. So the photodetector is basically just saying, yes, you ejected an electron, that's electricity. Ejecting an electron, moving it in a sequence, that's electricity. So the only way we detect a photon is to cause an event. All right? And the event is basically saying, I need a clump. Okay, give me a certain amount, or there isn't any cascade. There isn't any amplification. There isn't any event. So the event, we detect them as clumps. They don't necessarily come as clumps. They might have hit, and there might be something, could have been a photon, except, well, this one was a little behind. So the cascade didn't happen because you hit it, and then it went backwards. So you didn't hit it in sequence, and therefore it never went forward. That's all. You just have to take something out of frequency, and now all of a sudden, the clump, this collection, isn't going to be seen as a photon. It's still a collection of clumps. It's still a collection of items or bits, but it's not a clump, okay, because it doesn't have the proper frequency. It doesn't cause the proper effect. But it's just kind of wrong to say that Einstein had good reason to say a photon is a blob. There wasn't a reason to say that. To say that to see a photon, it has to have a certain character. It has to hit certain minimums. That's fine. But they went too far. I mean, you can't push half an electron. That part you might understand, right? It's a clump because electrons are clumps. It's detecting the movement of an electron. Okay, so then it's literally doing that in the photodetector. The device we have. It's the most obvious in the photomultiplier, right? Because the photomultiplier is basically saying, hit me with a photon here, okay? And if I eject an electron, then we have a photon automatically because a cascade happens. So all I have to do is eject one here. So it's obviously electrons that come in clumps. Electrons are, you can't send half an electron. Oh, I sent half an electron to that plate. No, I can't do that. I have to send whole electrons. And for every electron I eject is a photon, photon, photon. So the electron is telling you, I need a full quantization of energy to hit here to eject the electron. And I can't send half an electron. And I can't send it halfway. The rule is I got to send it from here to here, and if it doesn't do that, then it's not a photon. But there's no half electron, so that's why there's no half a photon.
Called photons. Einstein demonstrated this through the photoelectric effect, but his clue came from the quantized energy levels of Max Planck's blackbody radiation law.
Yes, well, again, it doesn't. All of these things have to do with understanding the fact that this stuff happens first over time. Okay, there's certain events have to happen, and the photon isn't just a clump. It isn't an event that happens now. That's it, photon. Photon is a sequence. That's the whole point of recognizing it has a frequency. Frequencies can't happen. Boom, it happened. That's not how a frequency works. A frequency works by its very description. It has to happen, and then it has to happen, and then it has to happen, and then it has to happen. It's events. So photons always, always, always should have been emphasized, even back then, as an event. A series of events. That's the frequency. It's so literal. It's so built into the very concept. And yet they describe it as if photon. Didn't take any time at all.
Check out our episode on this for the details. Okay, so each photon is a little bundle of waves. Waves of electromagnetic...
Yeah, so again, they assert it as if they have lots of... He showed us all the great evidence, and it really isn't great evidence, right? Seems like, looks like, it doesn't even seem like, and it doesn't even look like when you really look at it.
Field. And each bundle can't be broken into smaller parts.
So he just said it. It can't be broken into smaller parts. Who made that law? Where? Where did they prove that? Where did they prove they can't break the bundle? All they proved was that the photon detection requires a whole electron to move it. But the energy that moves the electron, certainly you could break it into clumps. You could have this much frequency, you could have this much frequency, you could have 20 little, bullets or waves. I mean, the very idea that he's just said, basically just said to you in a sense that the photon, if you're going to think of it as waves, right? So if you're going to think about it as this lumpy stuff, he basically just said, okay, you can't break this into clumps. You can't separate. So this is a photon right here. And this is a photon right here. Okay, and you can't break those into clumps. Well, yeah, that you can't break. But do you really think that a photon is just one of these? Just one wave? One wave is a photon. Well, then why are they drawing it with all these waves? And how do they explain polarization? I mean, no, not going to work.
That means that each photon should have to decide whether it's going to go through one slit or the other.
See, this would be fine, this description, little bits, fired at, see, all at a frequency, but they got two frequencies on this one, which doesn't make much sense. And just show it as the little bits go everywhere. They go through the slits and they scatter all over the place because, they're hitting electrons on the surface of the slits and they're getting shot all over this target. And where they're back in phase, photon. Where they're not in phase, no photon. Very simple.
Can't split in half and then recombine on the other side.
Yes, they can. See, that's exactly what they can do. So if you thought about it really, you said, yeah, I could throw something that's solid through slits. So I could imagine rabbits, and I could throw them at these slits, and I could understand that I just tore that little leg off of one rabbit, and its head flew off over there, and the pieces are flying all over the place, and that at the other side, where the pieces were in the right order again, head, body, tail, I have a rabbit.
That shouldn't be a problem, as long as you have at least two photons. One photon passes through each slit, and then...
So you do need more than one to make contributions. So this is another part where they should know that there's something wrong with their experiments, and there's something that just doesn't make any sense. Because here they are telling you something like, that seems kind of extraordinary. Because their own math knows that they need both sources. That you can't redo these photons. You can't have any of this effect because you really are just, taking a vector from one place and a vector from another place. And if I sent in one photon, how am I going to make a vector from here and a vector from here? The photon really can't hit both of these, especially if this is a numerous wavelengths. If I open this slit wide enough so it's like a half a millimeter or something, you're going to get 2,000 wavelengths in there, and you're going to get little tiny bars. There's no way one photon could hit both of these surfaces. I mean, how can it do that and create vectors? So it doesn't make any sense.
Two photons interact.
But they'll go past that. They'll just walk past the part that just doesn't make any sense.
With each other on the other side and produce our interference pattern. But here...
So again, he draws it now incorrect. So let's understand it's the two slit. We know the two slit isn't just that piece in the middle. We know it starts up again. It keeps, making another pattern. So this is just part, there's no way of looking at this except to say, well, that's pretty dishonest. If you showed the real pattern, then people would say, gee, that's more complicated than this. This doesn't explain that at all. How are you going to do that with two little waves? Two waves aren't going to make that complex pattern.
We get to one of the craziest experimental results in all of physics.
Right, so here we go. So it's a crazy, extraordinary result, and what are we going to provide as evidence? Ordinary crap. It's not even a good. It's not even close to good evidence.
The interference pattern is seen, even if you fire those photons one at a time.
So the notion that we know what a photon is when we're firing it, right? If these are composite objects, if the waves can be numerous sizes and shapes, you could understand, and we can only see certain sizes and shapes, specific ones, you could understand that there could be lots of photons that just aren't quite right. Like they could, I don't really want to draw the wave part, but just understand that when I draw a little blit, it's just like a node in one of your waves. So if you have to believe in waves, it's just a node. This is where the wave goes down. Let's just say, or this is where it equalizes. Just pick any part on your wave and just say there's a blip, and there's another blip, and there's another blip, and all, the theory could just simply be that, there's lots of energy that might be in this condition. Well, that won't be seen as a photon because the frequency changed. Just like our radio receivers couldn't receive that, the photo detector isn't going to receive it. It's not going to know it's a photon. So I can do different things to change its arrangement. I could put it, kind of far apart, out of alignment, and, well, that's not going to be seen as a photon. Lots of reasons why there could be lots of this little stuff flying around, and we don't know that it's a photon. It's energy, but it could be quite invisible to us. Just like the cell phone calls going right through you right now. Quite invisible to you.
Well, let me back up a bit. The first photon is detected as having arrived at a very particular location on the screen. The second, third, and fourth photons also. They deliver their energy at a single spot, and so they appear to be acting like particles of well-determined position. But check it out. If you keep firing those single photons, you start to see our interference pattern emerge once again.
Alright, so they're saying overtly, look, we're sending single photons. Only one photon, only one pile of energy, only one blob of blob is going through the experiment at a time, and therefore this can't be made out of pieces. Can't be made out of, stuff flying off of this one and stuff flying off of this one in pieces, or any kind of argument like that. And yet, their evidence that they've ever even done this experiment correctly doesn't exist. Nobody's done it over time. Okay, so any example of this experiment being done is cheating. The only way they can make it work is to cheat. So they imply that, oh yeah, we know there's only one photon at a time hitting the target. They don't know it at all. They have no idea what's hitting here. They can't test it. Well, they actually could test it, but they don't test it. Like LIGO, they don't do any testing. They don't see what actually happens here before they put the slits here. Like they could have this little emitter and then they could put a target here and just see what's hitting the target. They don't even do that.
By the way, Veritasium actually conducts this experiment in his excellent series on the double-slit experiment.
Right, so he doesn't conduct the experiment in a rational manner, and as I have already exposed. So Veritasium, like this guy, is just kind of a liar, right? Because Veritasium knows, I mean, this isn't really tough physics, right? You know that if you were in this position and you were doing this experiment, you would know, hey, I can see what I'm doing here that's just not quite right. So there is this thing called a photomultiplier, and it costs, some money. So Veritasium had a kit that they sell for $5,000, right? And it's just basically an advanced photo detector, okay, a photomultiplier, all right, and it's just, a little place for your slits and silly little light sources. You can have a laser, way overpriced actually, right? This is the only part, well, this and the counter. So there's a photon counter attached to this that can count your photons, 1, 2, 3, 4, 5. And so these two pieces of equipment might be worth $1,000, but the rest of the thing is a piece of crap. But anyway, and the photo detector has a sensitivity. You can crank it up, okay? You can apply more voltage to the plates, and so now electrons can be kicked easier, okay? Less photon has to hit them, okay, to make the electron jump, to say, hey, I clump, 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 clump. And so when Veritasium, right, so when you're doing experiments, right, and you put this photodetector in complete darkness, you put it in complete darkness, it's in a, tin can or whatever, you can turn it up where it starts picking up like cosmic rays and gravity. It starts picking up little discrete stuff, but you got the setting way up sensitive wise. You're instead of 100 volts, you're putting 500 volts on this thing or something, and you're making electrons really, really, really easy to push to this other plate, to say clump. And so when Veritasium's doing the experiment, he has this thing in complete isolation, and he's still getting 7 photons a second. 7. Okay, so that's not good, right? Because these photons you want from this experiment aren't magitons. They aren't some kind of special thing. You shouldn't have to have it way cranked up like that. You should be able to have it cranked up so you get 0 in the dark. That's what he should have looked for, right? He should have said it. Like if you were doing the experiment, you'd say, all right, have it completely in the dark. No photons are coming through the experiment. I should have 0 on here. Let me put the sensitivity on so this thing says 0. It's in the dark, and now I turn the light on, okay, and now I'll count the photons that go through the slits, blah, blah, blah. But he had the sensitivity cranked all the way up. You really can't crank it up much higher, I don't think. I mean, 7 a second is a lot of cosmic rays or whatever. You're detecting a lot of crap. You're getting a lot of jumps, electron jumps. So it's, clearly he knew that. He knew, hey, he probably did it the right way first, right? He did it the right way. He said, okay, let me turn the detector, 0 error photons. Okay, so now I'm only detecting the photons that actually are coming from my emitter. I'm sure he did it the right way, and you know what he found out? Hey, this experiment doesn't work. No photons are getting through. I'm not getting any results. I'm not getting any pattern. That sucks. How can I prove my physics if it doesn't work? So clearly he had cranked it up, which means when he cranks up the error photons, that if you're getting 7, error photons a second, then you have to crank up the speed of your light. You have to make the whole experiment happen much faster because you have to overcome this huge number of error photons that are popping into your data. And if you look at his final data, it's still full of errors. 50% of the photons that he saw were error photons. They weren't pattern photons. Can you see that? Yeah. So 50% of his data was error. right? And why? Because he had this cranked all the way up, and therefore he had to speed this up. So he didn't do the experiment over a week or a month or 2 months, really being sure I'm only getting one photon through at a time. No, he did it over 10 minutes, or whatever. And therefore just completely compromised the validity of the experiment, changed the facts. So the fact is, you could be sure, you could be certain no two photons could be here at the same time, or you could be really uncertain by speeding it up and saying, well, I can't be sure now. And that's all he did. He changed the certainty of there only being one photon in the experiment at a time by forcing the experiment to take place faster because he had too many error photons. Now, what I just explained to you is not at all complex physics, right? It's not. You can't believe that Veritasium doesn't know this, that he doesn't know having the, when he turned that photodetector all the way up, he had to be saying to himself, this feels like cheating. And when he changed the experiment he wanted to do over, say, 5 hours into an experiment that happened in 5 minutes, he had to be saying, why am I having to do that? It should have worked, right? It probably occurred to him, the words, hey, that should have worked, and it didn't. But that's not the honesty we get from these people, because they're religious. And religious people are fundamentally unreliable and dishonest.
Really worth a look.
No. It's worth critique. It's worth analysis. It's worth asking questions. How careful were you? These are important words now, because we obviously can see they're not very careful. How good was your experiment? How well did you perform it? Did you have a motivation going in, like I wish to prove it, and therefore you perverted the experiment, you forced the experiment to work? Those are legitimate frickin' questions. Are they forcing LIGO to work? I'd like to say, are they forcing the Eddington experiments to come out right, but they don't do any?
This is so bizarre. This pattern has nothing to do with how each photon's energy gets spread out, as was the case with the water wave. Each photon dumps all of its energy at a single point. No.
So again, each photon, blah, blah, blah. Again, I would argue that's not what happened. The fact is, two photons did get to the slits at the same time. They broke, and you recombine the pieces into another photon. And that's what actually happened.
The pattern emerges in the distribution of final positions of many completely unrelated photons.
So let's understand that the dark spots are not nothing. There's real energy still going there. Real pieces of photon are still hitting there. And the only difference between where you see the photon and you don't see it is phase. If the pieces are out of phase, they can't create the stimulus for electricity.
How can that be? Each photon has no idea where previous photons landed or where future photons will land. Yet each photon reaches the screen knowing which regions are the most likely landing spots and which are the least likely.
So again, it's all based on the assumption that the Veritasium video, or that the previous experiments where they claim this function, were done with some sort of integrity. I can't find the single photon, done the way it should be, which is we have no ability to create a single photon. We don't have a gun that makes one photon. So the only way you can make a single photon is you have to fire a bunch of bullets and then create a bullet filter, something that suppresses most of the bullets but lets one through now and then. And so to guarantee that that filter is working, that is, it never lets two bullets through, right? You really have to have it minimized. So you really have to do this experiment over as much time as possible. A day minimum. Week better. But the longer you do the experiment, the longer it takes, the more likely your results are going to be accurate. Now, the French guy who did it originally more than 100 years ago, 200 years ago, 150 years ago, whatever the hell it was, that we don't have any data from. Apparently, he let it sit for a month. He created so dark a screen for the bullets, that it took a month for enough light to get through to create a pattern, to expose the film. If you want to do it honestly, that's the kind of way you have to do it. But again, it really doesn't tell you the truth, because you're just measuring when there are 2 photons that get through. So it still doesn't guarantee you don't have 2 photons in the experiment, because the only time you're going to see the photon, the only time it's going to survive the travel, is when there are 2. If there's 1 photon, it's not going to make any light. It's just going to break, and there's not going to be any remade photon. It's likely to break, and especially the smaller the slits are. The bigger the slits, then you got some hope.
It knows the interference pattern of a pure wave that passed through both slits equally, and it chooses its landing point.
So we know that it doesn't travel through both slits. We know that there's 4 waves required to create the pattern. So it still doesn't make any sense that, okay, the photon split in 2 and creates 2 waves. No, it splits in 4 and creates 4 waves. So they're not telling you the truth, and their own math knows it. Their math knows that they need 4 point sources to explain the real pattern. So they'd have to tell you, no, the single photon breaks into 4 waves. And the more they start saying these things, the more you should be saying, that can't be the right answer.
Based on that, it turns out that the photon isn't the only thing that does this. Shoot a single electron through a pair of slits.
Alright, so I've been over this before, but wow. I mean, the way they just gloss over this electron argument. So photons are composite objects. They're made of bits. Now electrons are solid. There's no evidence electrons break down into anything or decompose into anything or can be broken into clumps of electron. But the thing to understand is a photon is a composite object, and the composite object's flying through space, and it has the polarization is proportional to the wavelength. It's actually the same, but it doesn't matter. Alright, so it's basically a very large object in the sense that, like an atom, okay, an atom can be understood as being 99% empty space. Well, a photon is likewise 99% empty space. It's just little tiny bullets in a gigantic amount of space, especially radio waves. I mean, there's a huge gap between the clumps, okay, miles and miles and miles, can be. So it takes up a lot of space in a sense. So you can understand where 2 slits could be a real problem for the photon, because this is what, I mean, literally, this is kind of what's going through, okay, is something that is, it can be, yes, it can be 2,000 of them could fit in here, or 550 or 100, and the more you fit, the smaller the little bars get. But the point is that they're certainly big enough to understand that they would crash into this thing and get broken. That this one would go away and this one would go away, and that you'd only be stuck with these 2 survivors. And the 2 survivors, if they go through the middle, they're fine. But if they, are deflected in all of these different scattered directions, they scatter, then they're hitting all over this surface, and again, it's just about putting them back in phase. So they're just pieces. So you can understand how photons can get broken, because they're big, relative to atoms. A photon its polarization is 2,000 atoms wide. Very big. It's lots bigger than atoms. Electrons, on the other hand, are tiny, right? So how am I going to make a slit for an electron? Just think about it. I mean, it's impossible, because what does this really look like? If we zoom into this, what does it really look like? Oh, that's right, it's an atom. And what's an atom? Oh, an atom is, a little tiny nucleus, electron way out there, and a bunch of empty space. So how am I going to make a slit? A confinement for an electron. I'm going to send this little bit to 2 atoms that are here, right? So let's just make the protons bigger so you get it. That's a proton in the nucleus. There's the electrons. and I'm going to make a slit out of electrons for an electron, and then electrons are charged. This surface is always going to have electrons on it, right? I mean, it's always going to have electrons on it. And so what? I'm going to send the electron through charge? How could the electron possibly navigate the slit as a free entity when it's charged? It's impossible. And so all that's really happening is that you could possibly do is you could have one electron get close to another electron, and what will the two electrons do? They'll deflect off each other, right? They never hit each other. One of them is they're pushed by the charge. This one will go that way, and this electron will go that way. So the electron will change its path because of the charge. All right, and you might get a pattern. But you can't make this slit. This thing is, we'd have to be able to manipulate atoms to be able to make slits. How could we separate two atoms, okay, to make slits, okay, for an electron to fly through? It's impossible. It's silly. It's nonsense. The gap would be insanely gigantic. So instead of the photon being, let's say, what would proportion? 1% smaller than the slits, or however you want to think about it. You could get 2,000 of the at a maximum. You could probably get more than that. But anyway, to see them. But an electron is millions. So you're talking about a slit that would look 1,000,000 times big, like 1,000,000 miles wide. How could you confine an electron? Most of the electrons would never get anywhere near another electron if we could actually build slits, if we could build atomic slits, let alone material ones, real ones. So the very notion that they're ever doing a slit experiment where you could actually force an electron into a confinement is ludicrous.
And it'll also appear to land at a single spot on the screen.
What they're seeing usually in these experiments is a fluorescent screen lights up, and that can light up from X-rays. And so when you're shooting electrons, electron guns shoot a lot of other energy with the electrons. Lots of stuff gets pushed off of the material. They're heating a piece of material. They're shooting basically the atoms. They're breaking the atoms into pieces and shooting them. All right, so lots of different radiation is flying out of the electron gun, and all they're really seeing is X-rays, probably. They're just doing the experiment with X-rays.
But fire many electrons, and they slowly build up the same sort of interference pattern. This crazy effect.
Same sort, he says, right? But it's really not dissimilar. I mean, it looks very different. It actually does gradually turn on and gradually turn off. It has a lot of features that the other experiments are supposed to have and don't. But again, one has to doubt the plausibility that he could ever make such an experiment. We can't manipulate. We can't create a slit small enough to create a parallel to the double slit in light. Photons, by coincidence, the thing called a photon, right, is much, much, much bigger than an electron. Huge. It's gigantic. 1,000,000 times bigger than an electron. But the quanta, the little bits inside the photons, are like 1,000,000 times smaller than an electron. That's the piece they don't understand.
Has even been observed with whole atoms.
So they say, again, the results are so meager and pitiful that he's pushing credulity once again.
Even whole molecules. Buckminster fullerene, buckyballs, are gigantic spherical molecules of 60 carbon atoms and have been observed to produce double slit interference under special conditions.
Under special conditions. And he said double slit interference, right? Double slit interference should mean the two patterns, right? That has, as far as I no picture of that. We're not going to see any of this evidence, by the way. Okay, because it's crap. But clearly, as I pointed out, if you start throwing real squirrels through slits, you will see pattern on the wall. You just have to dissect the pattern and figure out, if you throw the squirrels this way each time, with head to tail, you could kind of understand that mostly tails will be hit off of one slit and mostly heads will be decapitated off of the other one. And you can kind of get the idea that you actually are going to get a pattern, because one surface is going to be shooting heads and one surface is going to be shooting a lot of tails.
We have to conclude that each individual photon...
We have to conclude. So just remember, this is their rhetoric. You don't have to do that at all. There's lots more research and thought that could go into this to figure out maybe there's a simpler explanation. Maybe there's a simpler explanation. And knowing that, seeking that, you can find it. It's available. It's sort of obvious. But anyway, and then it has this preposterously giant surface with tiny, tiny slits, right? Nobody does it that way, but whatever. And this isn't the pattern. So again, just understand, he keeps showing the double slit now with a different pattern. So he showed the right pattern once, and every other time he shows the wrong pattern. A part of the pattern. An incomplete picture. Why does he keep doing that? Why is he as it to take too many little pieces of light or something? He's going to wear out his LEDs or something. You know, his graphics. Why can't he just show us the rest? Oh, that's right, because there's no way these two waves can explain the rest.
Electron or buckyball travels through both slits. There's some sort of wave. That wave then interacts with itself.
So again, what sense is there? Is he saying this piece of chalk is a wave, you know, and it's going to interact with the universe based on waves? When no, there's little light vectors coming off of it right now. Light's reflecting, the vectors are coming off in straight lines. It's, you know, rays of force. That answer is so much better than some notion that this is waving. It's not waving.
To produce an interference pattern. Except that here the peaks of that pattern are regions where there's more chance that the particle will find itself. It looks like a wave of possible undefined position.
It looks like. Yeah, it's a pattern. The simplest pattern in the universe, by the way. And again, it's one you haven't done any, you haven't gone to any effort to sit there and twist and turn the experiment to see what you can make it do, to test it, to see if it can give you more information. You got what you wanted out of it, and that's all you want.
But at some point, for some reason, resolves itself into a single certain position. We also saw this waviness in position when we talked about quantum tunneling. In fact,
complete crap. I mean, nothing tunnels, it's just nonsense.
Several quantum properties like momentum, energy, and spin all display...
All nonsense. All just... Momentum is a real thing, but they turn that into frequency. They decide that frequency equals momentum, which is just plain silly.
Similar waviness in different situations. We call the mathematical description of this wave-like distribution of properties a wave function. Describing the behavior of the wave function is the heart of quantum mechanics.
Right, and so the heart of quantum mechanics is a function that there's no reason you have to believe even exists as any kind of real thing. The fact is there will be a cause and an effect, and the proper dissection makes it easy to understand. There's no wave function. Obstacles break things, and after you go through the obstacles, there's a bunch of parts flying through space, and you can remake things out of the parts. That simple explanation does away with this whole need for any of this quantum woo.
But what does the wave function represent? What are these waves of, or waves in?
Well, you're certainly not going to explain any of that, or come even close to anything like an explanation. And how is it polarized? How the hell does it do that? And why is the polarization gigantic?
Let's start with what we do know about the double slit result. We know
oh dear.
where the particle is at both ends. It starts its journey wherever we put the laser, or electron gun, or buckyball trebuchet, and it releases its energy at a well-defined spot on the screen. So the particle...
So all we know is that we start with something, that if we put a screen there, we'll get photons. We got whole photons. They're working. They're complete squirrels. we shove the squirrels through the slits, and the squirrels are ripped to pieces, and a bunch of pieces hit the wall, and in certain places we can put a squirrel back together. And that's it. That's all you need is an explanation. Nothing more. Not any more complicated than that.
Seems to be more particle-like at either end, but wave-like in between. That wave holds the information about all the possible final positions of the particle.
So this should be a giveaway, right? It looks like this, but then it looks like that. It looks like, well, and they're different things. It can't be both things. It's silly to think it is both things. So the simple answer is to say, oh, these things I'm calling a particle are really made out of pieces. Okay, the car is made out of pieces. I can tear all the pieces apart, throw them in a pile somewhere, and then I can put them back together again and make a car. You know, I can transport something really big, like a house. I can transport it room at a time to a location and rebuild and build the house. There's lots of things or examples where we know that, yes, you can take something apart, send the pieces through a little tiny hole, right? And then put it back together as a big giant thing.
But also about its possible positions at every stage in the journey. In fact, the wave must map out all possible paths that the particle could take.
So he didn't draw all possible paths that it could take. So anyway, so again, this is just, it sort of just begs credulity. They say this is the only possible answer is some kind of crap like this. You know, that they went everywhere, and you know, there's a new universe where it's someplace. I mean, it's just too silly.
You have this family of could-be trajectories from start to finish. And for some reason, when the wave reaches the screen, it chooses a final location.
So, you know, it chooses a final location, but if it hit the wall and reflected over here, it certainly didn't choose among these choices. So it already got chose when it hit the wall and bounced off of it. It never even... So, you know, it's just so silly to think that the thing bouncing off the wall is aware of all the other choices it had. And, it, you know, it's not aware. Halfway through the experiment, it already made its decision. Game over. You know, it already annihilated all of that. But that's the joke of this, right? So we know all through this path, it's getting hit by cell phone radiation, right? The whole time any of this crap is traveling, we know it's getting hit by all kinds of stuff. It's, you know, if you understand gravity as a real force, we know that gravity is testing it all the time. Every little place it goes, gravity's testing it, testing it, testing it. Certainly we know that with electrons. So it's certainly being affected by things. So it's just kind of silly to say, hey, look, it's, you know, I mean, this is energy, and I would argue that energy isn't affected by energy. That is, force isn't affected by force. But I'm just saying they're claiming that electrons are doing the same thing. So just use the electron example to point out how could it possibly be in a superposition when it's constantly being observed by I just pick up somebody's cell phone. I just pick it up and make a call, and I've forced it to decide what universe it's in.
That implies choosing from these possible paths. So what causes this transition between a wave of many possibilities and a well-defined thing at a particular spot? Within that mysterious span between the creation and the detection, is the particle anything more than a space of possibility?
So he's saying the whole trip is completely uninterrupted by anybody with a camera. You know, nobody took a picture of the train on the whole trip. And we know the camera just means any form of radiation, any form of interaction with any force in the universe, you know, anything, a cosmic ray, anything. So we know it didn't make that whole trip without encountering something. So it's just kind of silly.
Okay, we're adding more questions than we're answering. We still didn't figure out what the wave is made of. In fact, the answers aren't known, but the various
Yeah, the answers aren't known. So that's the fact. So the fact is our theory kind of sucks because we don't know what to make it. You know, we can't even tell you what the elemental function is. We can't tell you anything. Nothing at all. We have no clue how this happens. And so we can just make up anything. Right? Because they're not limited by some notion or idea or rule that says, well, we have to fit it into this context of it being a force, and we have to obey these certain rules that forces don't do this and blah blah blah. But they're not obeying any rules at all. I mean, this is sort of just as obvious as, you shoot a laser beam in fog and, you see so much more of the beam. You can see the beam because the beam is hitting things. And that's exactly why you see it. The beam is hitting things. The photon doesn't go to the target. Instead, it goes to you and you see it. Well, that photon didn't keep going. I'm not seeing the photon. I'm seeing the photon in the sense the photon isn't part of the laser beam anymore.
Interpretations of quantum mechanics? Do try. Let's talk about the view favoured by Werner Heisenberg and Niels Bohr, who pioneered quantum mechanics.
Yes, who pioneered woo. Okay, let's just understand. Woo and wooier. Religious kooks, essentially.
Mechanics at the University of Copenhagen in the 1920s. The Copenhagen interpretation says that the wave function doesn't have a physical nature. Instead, it's comprised of pure possibility. It suggests that a particle traverses...
It's not true possibility, it's probability. So even that, what's that? True possibility. It's not true possibility. There's no such thing. It follows rules, and we know that there's going to be rules about any obstacle I create. I can't, if I throw squirrels through slits, there's certain things that can happen, and there's certain things that just won't happen. Okay, I mean, they'll come off spinning, they'll come off doing all kinds of things, but there's something I could describe where it spins this way and flies to Mars that, can't happen. It just isn't going to happen. There's no physical way the physical circumstances can cause that effect. And they just don't want to be confined by anything. But clearly, there's things that can and can't happen. So yes, they're going to fall in a scale of how many times does that happen? How often does it happen? And there'll be a probability of it happening. You can watch it. You can do it 1,000 times and see how often it happens.
In the double slit experiment exists only as a wave of possible locations that ultimately encompasses all possible paths. It's only when the particle is detected that a location and the path it took to get there are decided.
So again, this it's detected constantly. If it's an electron, it's, again, a photon, yes, you can't detect a photon without sticking a piece of matter in front of it and terminating it. Obliging it to decompose and recompose, to be exchanged, like the chalk. You can push the electron pushes another electron, that electron pushes another electron. You can cause it to do that, but you can't kill the energy.
The Copenhagen interpretation calls this transition from a possibility space to a defined set of properties the collapse of the wave function. It tells us that prior to the collapse, it's meaningless to try to define a particle's properties. It's almost like the universe is...
So again, he's saying that the electron travels through the experiment completely superimposed in some sort of state where it's meaningless to talk about its properties, when it's constantly being pushed by gravity and constantly being hit by radiation. We're supposed to believe it still doesn't know where it is.
Allow
bullshit.
All possibilities to exist simultaneously, but holds off choosing which actually happened until the last instant. Weirder. Those different possible paths, those different possible realities.
Even his own argument, you could fix it, right? I could help him by pointing out it doesn't do it at the last moment. Right after it leaves the slits, if I deconstruct it, I force it to be in one universe, then it's already at a trajectory. It already has a destiny. Because now I'm giving it a real point in space and a real velocity. And so it's already going to go over there, over there, over there, over there. And so it doesn't really matter. I mean, all I have to do is say it was superimposed for one instant, and then all the possibilities. And then I can immediately, cause it to collapse. And it's going to collapse in one of those positions that has a real vector in a real direction. They can't even just say that they can't even describe their own silly religion right. It's like, how stupid Christianity is in terms of they could clean up all the parts that are ludicrous. And they don't. And these physicists are just as bad at writing their Bible. They leave in parts they don't even need to leave in that are just stupid.
These interact with each other. that interaction increases the chance that some paths become real and decreases the chance of others.
Alright, well this is probably enough, right? We don't... it's just too silly. I guess is it going to do many worlds next and the next piece of crap? So now we're way distant from the actual experimental results. So we'll call it quits there. So, just garbage. Bad science. Just really bad science. This doesn't look right. Green? It shouldn't be green. Well, anyway, hopefully everything's okay. And this will be a video, hopefully.